Alright, number 1 in the review problems. Baseball has a mass of 0.2 kilograms. If the velocity of the pitched ball is 30 meters per second, and after being batted it is 50 meters in the opposite direction. So I'm going to call this the initial, and then I should just call this the final. Okay, and it's negative. Find the change in momentum of the ball. So delta P is change in momentum. It's equal to m delta V, which is equal to mVF minus mVI. So I have 0.2 negative 50 minus 0.2 times 30. So 0.2 is going to times negative 50 is going to be negative 10. 0.2 times that is going to give me 6, so that's going to be a negative 6. So I have negative 16 kilogram meters per second for the change in momentum. You might have a positive depending on how you picked your direction. Doesn't really matter. Just make sure that one is positive and one is negative. Okay, then it says if the ball remains in contact with the bat for 0.002 seconds, find the force of the blow. So F delta T equals m delta V. Delta T was 0.002 seconds. And the change in momentum we said was negative 16. So I'm going to divide both sides by 0.002. Those will cancel. My force is negative because it was hitting the ball to the left as I have it set up. Yours might be positive depending on how you defined your direction, and that's fine. So I'm going to say 16 divided by 0.002 gives me 8,000. So my force is 8,000 newtons. And it's either positive or negative depending on how you defined your direction. Okay. Number 2 on the review says a 0.42 kilogram ball, so mass is 0.042 kilogram ball, is dropped from rest at a point 1.1 meters above the floor, so H1 is 1.1 meters. The ball rebounds straight up to 0.8. What is the magnitude and direction of the impulse imparted to the ball by the floor? Well, impulse is J. J is equal to F delta T, which is equal to m delta V. So J is equal to m delta V. So I need to find the speed that it hits the floor with. And it's going to be the square root of 2GH. Now where did that come from? Well, PE here has to equal KE there. So I have MGH 1/2 MV squared. Masses will cancel. Finish out your algebra. So I got square root of 2GH for my velocity. So now I need to take 19.6 because that's 2 times 9.8. Multiply it by 1.1. And take the square root of that number. And I get 4.64 for that speed. So that's the speed it hits the floor with. The speed it leaves the floor with, the KE as it leaves, is equal to the PE as it goes up to 0.8 meters. So I'm going to say 1/2 MV squared equals MGH. Same relationship. So V is going to be the square root of 2G. H is going to be 0.8. So I'm going to take 19.6 because that's 2 G's. Multiply it by 0.8. And take the square root of that number. and I get 3.96 meters per second for my speed. I'm going to make that be positive as it heads up and make this be negative as it falls down. So that's the initial and that's the final. So J is equal to m delta V, so m was 0.420 kilograms. Delta V would be VF, 3.96, minus VI, negative 4.64. So now it becomes a matter of doing the algebra. So 3.96 plus 4.64. And I'm going to multiply that by 0.42 because that's my mass. And I get 3.61 as my change in momentum, or my impulse. 3.61 Newton seconds or kilogram meters per second, doesn't really matter. So there's number 2. Number 3. Number 3 says, what is the momentum of a 10,000 kilogram truck whose velocity is 20 meters per second? So mass is 10,000 kilograms. Velocity is 20 meters per second. So I'm going to multiply 10,000 by 20, and P is equal to MV, 10,000 kilograms times 20 meters per second gives me a 2 followed by 5 zeros. Kilogram meters per second. Part B says, with what velocity must a 5,000 kilogram truck attain in order to have the same momentum? So the momentum was 200,000. The truck's mass is 5,000. And we're looking for the speed of the truck. Well, cancel those, cancel those. 5 divided into 200 is 40. That's the speed of the truck. So I think we have successfully completed number 3. Let's move on to 4. A 2,000 kilogram automobile is going eastward at 60 kilometers an hour, hits a truck that's going southward, so we're going to have a collision. Okay, so this one's going east at 60 kilometers an hour. Mass is 2,000 kilograms. Speed is 60 kilometers per hour. The other truck is going to the south at 20 kilometers an hour. And it has a mass of 400. So I'm going to have a collision and they're going to do something like that, stuck together. So we got to figure that out. So we're going to do our x-axis first. M1v1x plus M2v2x equals them stuck together. Vx prime. This one was not moving on the x-axis prior to the collision, so I have 2,000 kilograms times 60 kilometers per hour equals M1 plus M2 is 2,400, if I did that correctly, a 2,000 and a 400, is that right? Yes, so that's 2,400 kilograms. Vx prime. These will reduce. If you divide both of those by 4, you'll get a 5 here and a 6 here. So I have 300 kilometers per hour divided by 6 kilograms. Vx prime is 50 kilometers per hour. I'm going to pause it for a minute and check my math. So that was fine. Now we need to do the y-axis. M1v1y, which is 0, plus M2V2y is equal to M1 plus M2, because they're stuck together, By prime. So now I have 400 moving at a negative 20 because it's to the south equals 2400 kilograms times By prime. Alright, so the kilograms will cancel. This will be 1. This will be 6. So negative 20 over 6 kilometers per hour equals Vy prime. Well, negative 20 over 6, that's the same thing as 3 1/3. So I have negative 3 1/3 kilometers per hour is equal to Vy prime. So now I have, to finish the problem, I have Vx prime is 50. And then I have this one is 3 1/3, and I pointed it in that direction because it's negative. So I need to find the hypotenuse, B, square root of A squared, which is 50, plus 3 1/3 squared. So if I can do that math, alright, turn this lovely iPad back on. So I have 50 squared. And I'm going to square my 3 1/3. And I'm going to get square root of that. I get 50.1. So it didn't make a whole hill of beans of difference. Actually, I should say 50.1. But I need an angle. I need that theta right there. So tan theta equals 3 1/3 over 50. So let's see if I can do that on this lovely calculator. So 3 1/3 divided by 50. Okay, now I got to do tangent to the negative 1 on this calculator. Alright, not seeing it on this calculator, so you're going to have to figure out your angle on your own. Not a big deal. You can do that. Alright, so I pretty much did number 4. I'm going to stop now, and I will do 5 through 11 a little bit later this afternoon. Got to go to church.